Hello students, welcome to our live streaming session on isomerism. Isomerism of organic compounds. It is included in the GOC part of class 11 syllabus, and also it is very important for the class 12 organic chemistry part, because isomerism is a general topic that covers all the structural difference with the same molecular formula in class 11 topic and also in the class 12 topic. Isomerism of hydrocarbon in alkane, alkene, alkyne are included in class 11 syllabus, and other isomerism like functional, like metamerism, like ketoenol tautomerism or other tautomerism, and other type of optical isomerism are in class 12 syllabus. In stereochemistry, there is a topic of geometrical isomerism, C-Strons isomerism and JEE isomerism, which is included in class 11 syllabus for alkene as well as in cyclic hydrocarbon. EJ nomenclature is one type of C-Strons isomerism, but in the C-Strons isomerism you have to find out the same type of group or atom with respect to carbon-carbon double bond or cyclic compounds. But in EJ nomenclature, the priority of the group or atom attached to the carbon has been identified to detect the Z or E. Z being Jusaman and E for it in Gen. Z is related to cis type of structure, same priority group or in the same side of the double bond or same side of the plane, and E is related to the trans type or anti type of structure in which same priority group are in the opposite side of the double bond or opposite side of the cyclic compounds. Mainly we are discussing the different type of isomerism and the structural difficulties in our today's live session class. नवरात्रि का तुम लोगों का हार्दिक शुभकामनाएं, শুভ ষষ্ঠীর শুভেচ্ছা, শারদ অভিনন্দন, শারদীয়ার শুভেচ্ছা সবাইকে. Now we are going to start our live session, and the detailing of different structures related to today's live streaming session on isomerism of organic chemistry. ठीक है बच्चों, तो स्टार्ट करते हैं आज का आइसोमेरिज्म इन ऑर्गेनिक केमिस्ट्री. আজকের অর্গানিক কেমিস্ট্রি আইসোমেরিজম আমরা স্টার্ট করছি. Isomerism of the different organic molecules with the same molecular formula having different structures. Now we are going to start the detailed discussion step by step. If you have any doubt or any question, please write in the chat box. First, our topic is isomerism. Isomerism of organic compounds. Isomerism of organic compounds. Isomerism of organic compounds, molecules with same molecular molecules with same molecular formula, molecules with same molecular formula, दोनों मॉलिक्यूल का सेम मॉलिक्यूलर फॉर्मूला मिलेगा. इसमें सेम मॉलिक्यूलर फॉर्मूला having different structure and different structure or various structure, different structure, different structures. The isomerism of organic compound. Mainly isomerism divided into two general category. First one is known as structural and second one is known as stereoisomerism. First one is known as structural isomerism. Structural isomerism, and second one is stereoisomerism. Stereoisomerism means different arrangement in three-dimensional space. Isomerism, stereoisomerism. Now first one, structural isomerism. Different structural isomerisms are there. In this category, our first case is chain isomerism. Chain isomerism means you have to create branching. You have to create branching by breaking the long chain structure. Next one, which is very important, ring chain isomerism. Ring and chain with double bond or triple bond or diene type of system, ring chain isomerism. रिंग भी है और इसमें चेन भी मिलेगा तुम लोगों को, दोनों एक ही साथ में. नंबर 3 इज नोन एज फंक्शनल ग्रुप आइसोमेरिज्म और functional isomerism. Functional isomerism is related to different functional groups with the same general formula. Functional isomerism. Next one, number 4 in this case is metamerism. In metamerism, in metamerism, functional group is same, but the alkyl groups are different with a different number of carbon atoms. Metamerism or meta-isomerism. Next one, tautomerism. Tautomerism, mainly keto-enol tautomerism. Tautomerism, keto and enol are the main isomers in equilibrium. Tautomerism. And another most important topic at the last part, which is related to the number 2 topic, which is ring chain isomerism. Du means degree of unsaturation or double bond equivalent or index of hydrogen deficiency or IHD. The formula is 2 into carbon number plus 2 into carbon number plus 2 minus number of hydrogen divided by 2. This formula is used for the keto-enol. This formula is used for the ring chain isomerism number 2 part after the keto-enol tautomerism. It is du. We will discuss this du, degree of unsaturation, DBE, double bond equivalent, and IHD in our next part. Now, stereoisomerism. Stereoisomerism is mainly divided into two parts. First one is known as geometrical and second one is known as optical. First one is known as geometrical and second one is known as optical isomerism. In geometrical isomerism, mainly two type of isomers C's, same group are in the same side of the double bond or plane. JD, same priority group are in the same side and trans with respect to E or A tangent. In optical part, only you have to identify the chiral molecules. Chiral molecules means carbon with 4 different groups or atoms. Chiral molecules, and number of optically active isomers is 2 to the power n equal to chiral number. Optical isomerism is related to the optically active isomers to rotate the plane polarized light. Now we are going to discuss the different type of chain isomer, ring chain isomer, functional, metamerism, tautomerism part. Our next part is examples and discussion of different part. First we are going to discuss the DU, DBE or IHD part. First one we are going to discuss the degree of unsaturation or double bond equivalent or index of hydrogen deficiency or IHD. These are the most important for any entrance examination like JEE Main and Advanced and NET part. The formula is du equal to 2 into carbon number plus 2 minus hydrogen number divided by 2. We are going to discuss different type of examples. First one, du part is not applied to the any saturated hydrocarbon. First one we are going to discuss for example 1 for DBE part, C3H6, then degree of unsaturation 2 into carbon number is 3 plus 2 minus hydrogen number is 6 divided by 2. Then the value is 6 plus 2 minus 6 by 2 equal to 1. What is meant by 1? 1 means 1 pi bond or 1 ring is there in the isomer. C3H6 with 1 pi bond. First one 1 pi bond, CH2 double bond, CH single bond, CH3. The compound is known as propene and cyclic compound with 3 carbon is cyclopropane. Then it is known as ring chain isomerism. The topic is very important. It is under ring chain isomerism. Ring chain isomers are there. Value of degree of unsaturation. Now our example number 2. Example number 2. In our example number 2, we are going to discuss different type of examples. C4H8. Our example number 2 is C4H8. Now, what is the degree of unsaturation value? 2 into 4 plus 2 minus 8 by 2 equal to 8 plus 2 minus 8 by 2 equal to 1. Again the same topic. 1 means 1 pi bond or 1 ring. 1 ring. 1 ring one ring. Now 4 carbon, first starting with CH2 double bond CH single bond CH2 CH3 but 1 in. Now CH3 CH double bond CH CH3 but 2 in. Next one CH3 chain isomer C CH3 and double bond CH2. These are the open chain isomers. Now ring. Open chain isomers. Ring is 4 carbon ring is cyclobutane. 3 carbon ring is cyclopropane with 1 methyl group, means methyl cyclopropane. Now another aspect is there, but2 in compound with 2 geometrical isomers. One is known as cis-but2 in, and another is known as trans-but2 in. Cis-but2 2 methyl group are on the same site. In the trans-but2 2 methyl groups are opposite in site. Means these are also known as ring chain isomers, and cis-trans isomers are known as GI or geometrical isomerism. These are known as GI or geometrical isomers. Means these are the examples. DU is mainly ring chain isomers. Ring chain isomerism. Ring chain isomers are included in this type. ओके बच्चों, तो ये रिंग चेन आइसोमर वाला हम लोग डिस्कस कर लिए हैं. अभी हम लोग दूसरा एग्जाम्पल में जा रहे हैं. We are going to discuss the next part of our isomerism part. Next one we are going to discuss. Next one is chain isomers. Chain isomers means you have to create branching. The formula is C4H10. Our first compound is C4H10. Cn H2n plus 2 means it is normally alkane part. Alkanes with C4H10. C4H10, first one, it is N-butane. And second one is 2-methyl propane or isobutane. These are the chain isomers. Next one we are going to discuss. Another topic which is known as ring chain isomerism. Ring chain isomers. Next one, we have already discussed ring chain isomers with different number C4H6. C4H6, you have to calculate the du value. 2 into 4 plus 2 minus 6 by 2. Minus 6 by 2 equal to 8 plus 2 minus 6 by 2. Then the value is 2. 2 means first one 2 pi bond structure. 2 pi bonds. 2 pi bond structure in 2 pi bond. First one cumulene, next one butadiene, and next one triple bond with 4 carbon, and next one at the mid position triple bond. These are the 2 pi bond structure. Now 1 pi and 1 cyclic ring. 1 pi plus 1 ring structure, 1 cyclic ring structure. First one 4 carbon with double bond cyclobutene. Next one 3 methyl cyclopropene. Next one 1 methyl cyclopropene, and next one cyclopropylidene, exocyclic pi bond. Now last one 2 rings. 2 rings means 2 value, means you have to complete all the options. 2 rings with bicyclo fused compound. It is bicyclo fused compound 110, bicyclo 110 butane, bicyclo fused system. Then 4 open chain and 4 cyclic and 1 bicyclo compound. Number 3. Okay, chain isomer, ring chain isomers. Next, we are going to discuss the different functional isomerism part. Functional isomerism means functional group isomerism. Functional group isomerism. Functional group isomerism with general formula C3H6O. C3H6O. Cn H2n O. It is a general formula. Now the structure is first one CH3, CH2, CHO. It is aldehyde. And next one CH3, COCH3. It is ketone. And another one is ether, CH3OCH double bond CH2. It is known as methyl vinyl ether. These are different aldehyde, ketone and ether. These are the different type of functional group isomerism. Different type of functional group isomerism. Functional group isomerisms are most important in this case. Now we are going to discuss another topic most important, which is known as metamers. Another topic we are going to discuss, metamers. Metamers. Metamers, metamerism or meta-isomerism, in which alkyl groups may be different with the same functional group. We are going to start with a star. We are going to start with a star functional group, C5H10O2. It is the first star in our case. The first one, CH3, CH2, COO, and again CH2, CH3. Ethyl propanoate is the first case. Next one, ethyl propanoate, and next case CH3, CH2, CH2, COO, CH3. Now the metamers are, the functional group is COO, COO. The carbon number is, in the left hand side is 2 carbon and in the right hand side 2 carbon. In the left hand side 3 carbon and the right hand side is 1 carbon. 2 carbon alkyl, 2 carbon alkyl, 3 carbon alkyl and 1 carbon alkyl. Means alkyl numbers are different. Alkyl numbers are different. Next one, our case is ether. Our next case is ether. Ether starting with C4H10O, CH3, CH2O, CH2, CH3, or C2H5. It may be CH3CH2 or it may be C2H5. 2 carbon diethyl ether. In the next case of metamer, CH3O, CH2, CH2, CH3, means propyl group is there, then 1 carbon and 3 carbon, means different alkyl groups. Now our third case in our metamer section is anhydride. Anhydride or acid anhydride. Anhydride is our next case. Anhydride. Anhydride C6H10, C6H10O3. Our next case. First one, CH3, CH2, CO, O, CO, CH2, CH3. The functional group COOCO, carbon number, carbon number, 2 carbon, 2 carbon in the both side. But in our next case, CH3 CO O CO CH2 CH2 and CH3. In this case, 1 carbon in this side and 3 carbon in this side. Means alkyl numbers are different, but these are not the position isomer, because position isomers are completely different from metamers. Position isomers are considered with respect to position of the functional group or any group, like orthobromo, metabromo and parabromophenol. OH group phenol, bromine in number 2 position, it is known as ortho. Now bromine in the meta position OH and bromine in the meta position, it is known as metabromophenol. And another case is bromine just opposite side of the phenol, it is known as parabromophenol. Then these are the change of position of the group, change of position part, like double bond also. Another example, CH3 CH2 CH double bond CH2, and position of double bond changes from 1 to 2. It is but 1 in number 1 position and it is number 2 position, but 2 in. These are also known as positions isomers. Metamers, functional isomers and the position isomers, these are the different type of isomers we have already discussed, and these are the main examples of isomers. Now we are going to discuss the another topic which is known as Tautomerism or ketoenol tautomerism. Tautomerism or ketoenol tautomerism. Tautomerism or we are going to discuss main topic which is known as ketoenol tautomerism. First one, starting with aldehyde group. CH3CHO. CH3CHO, this carbon is known as alpha carbon. And alpha carbon alpha carbon and removal of this alpha hydrogen because it is acidic due to minus I effect of CO group. Then O minus is formed and hydrogen goes to oxygen point. Then it creates the double bond with this type OH and H. It is known as keto due to carbonyl, and it is known as enol. In plus all equal to enol form. Keto and enol are in the equilibrium position. Hydrogen goes to oxygen, and the mechanism is also known as intramolecular proton exchange or IMP mechanism in this case. But if you start with active methylene type compound like this, cyclohexane 135 trione, then each and every CH2 group are highly acidic in nature. Highly acidic in nature, then removal of hydrogen and formation of double bond, it creates aromatic compound. It creates aromatic compound, in this case benzene derivative, double bond, and the OH group and OH group. It is aromatic, benzene 135 triol, due to aromatic stability, aromatic stability, almost 100% enol form, 100% enol form. Equilibrium is shifted towards right hand side in this case of enol form. Because the compound is aromatic, it is benzene derivative, benzene 1,3,5 triol. Aromatic compound satisfy Huckel's rule of 4n plus 2 aromatic stability. Ketoenol tautomer are always in equilibrium. Equilibrium shifted towards enol due to stability of enol form. Equilibrium, always in equilibrium, but in this case of keto with sp2 carbon in alpha and 2 methyl group at the position, and this type of compound 2sp2 alpha carbon, these are 100% keto, 100% keto form, because enolizable alpha hydrogen is not present. 100% keto, no enol form. कोई भी एनॉल फॉर्म इसमें नहीं मिलेगा तुम लोगों को, कोई भी एनॉल फॉर्म नहीं है. तो it is the first example, it is the second example, and it is the third example. Now the fourth example is in ketoenol tautomer. It is pentane 1,3 dione type system, means 2 and 3 position with ketone, and 1CH2 is active methylene or acidic part. Now the removal of hydrogen and formation of enol gives hydrogen bonding in the enol that increases the enol content, and also resonance is there, intramolecular hydrogen bonding, or it is known as chelation or hydrogen bond formation that increases enol form increases by hydrogen bonding and resonance also. These are known as keto-enol tautomerism type. Now we are going to discuss most important topic, which is known as cis-trans isomerism or EJ type of isomerism in geometrical isomerism. In this case, you have to study the carbon-carbon same plane, geometrical isomerism. Geometrical isomerism first case is our cis-trans isomerism. In cis-trans isomerism, but2 2-methyl group are in the same side means cis, and 2-methyl group are opposite side means trans. It is cis and it is trans. Very simple. Next one, in cyclohexane type, Wedge dash formula, one bromine above and another bromine above, and 2 hydrogen atoms are below the plane. It is cis, and 1 bromine above and another bromine below, 1 bromine above, hydrogen below, and in other case hydrogen is above and bromine is below the plane. It is known as trans isomer. But in case of other examples, if one is matching, then alcohol like this and another is alcohol, but in this case is CH3, then 2 OH group are on the same side of the plane means cis, but in this case 1 OH group above, H below, and in another case CH3 above and OH below, it is trans, means cis-trans category. We have already discussed the cis-trans category. Now we are going to discuss the EZ nomenclature category. EZ nomenclature category. E means trans type or anti, and Z means cis type. E means trans type, trans pattern, and Z means cis pattern. Now first example is here. You have to identify the EZ part. First one, OH and H, and bromine and CH3. You have to identify the priority part. OH is 1 and bromine is 1. Hydrogen is less priority in this case. In this case methyl is less priority, 1 1 same side. Then it is Z isomer. Now another example is here. First one, hydrogen and COOH And second one case, in the second one, C2H5 in this case and methyl is in this case. Atomic mass, molar mass or priority of the series 1 2 and 1 2. 1 1 opposite site means it is known as E isomers. E isomers. Another example of EZ. Another example of EZ nomenclature. First one CHO and H, and second one is bromine and chlorine. CHO is the priority 1 and hydrogen is priority 2. Bromine is the priority 1 and chlorine is the priority 2. 1 1 same site means Z isomer. Means EZ nomenclatures are based on this type of priority. Now we are going to revise all the slides. We are not discussing any optical isomerism in our today's session, because optical isomerisms are mainly related to different type of mechanism SN1 and SN2 in our class 12 syllabus, that will be covered in our next live session. Now we are going to revise all the slides. First one, isomerism, general slide. Chain isomerism, ring chain functional metamerism, as well as position isomerism also. Position isomerism and tautomerism and DBE IHD part. In this case, you have to include another part which is also known as position isomerism, and geometrical C-strands and optical part. Today we have already discussed the geometrical part also. The second one, DU, DBE or IHD part, in which we have already discussed the number of pi bond and ring present in the open chain and the cyclic part. Next one, chain isomerism, ring chain isomerism and functional group isomerism. Chain isomerism means branching, ring chain means number of pi bond and cyclic, and functional group with different functional isomers. Next one, metamers as well as position isomers. In the metamers, same functional group with a different number of alkyl with respect to one functional group, but in position isomers, position of the double bond, position of the group or atom or functional group may be changed. In the keto-enol tautomerism, you have to identify the percentage enol content in the compound with IMP mechanism, intramolecular proton exchange type, and keto and enol forms are in equilibrium, and alpha hydrogens are removed from the system to attach with keto. Last topic is stereoisomerism part is geometrical isomer. Same group, same side of the double bond is cis, and different group, different side of the double bond means trans. These are the main topic, and cis related to cis-trans related to same type of group, same group or same atom, same group or same atom, but it is related to same priority part, same group or same atom, but ZE related to same priority group. Okay, thank you. Thank you to all of you, and we have already discussed all the topics except chiral and optical part that will be covered in our next live session. Thank you very much. Happy Puja, Shubho Shoshtir, আন্তরিক শুভেচ্ছা ও অভিনন্দন। গুড নাইট, বাই।